Good morning, everyone. Let's take a surprise test to see how well we have understood AWS so far. These questions have been taken directly from the AWS Solution Architect Associate exam. If you are lucky, some of these questions may appear when you take up the certification exam. Let me evaluate each of the options given and pick the correct one so that it will help you to understand better and know why we picked that answer. So here is the first question. A company is planning to migrate a TCP-based application into the company's VPC. The application is publicly accessible and can process up to 3 million requests per second. The company requires the same level of performance for the new public endpoint in AWS. As a solution architect, what do you recommend to meet this requirement? We have 4 options to choose from, and there is only one correct answer. Let's evaluate each of the options. Option A is network load balancer configured to publicly accessible over TCP port that the application requires. Obviously, this should be our first choice because network load balancer is made to work with both TCP as well as UDP. Let's also examine other choices that we have and let's see, will it go well with our requirement or not. Option B is application load balancer, configure it to publicly accessible over TCP port that the application requires. Actually, application load balancer is used to route traffic in HTTP and HTTPS. So this is not made to work with TCP and UDP. So this option B is ruled out. This will not serve the purpose. Moreover, it will not work with TCP and UDP. The third option is option C. It is about CloudFront. CloudFront actually is made to deliver the static content like images, JavaScripts, web pages, so on and so forth. So CloudFront distribution supports, once again, HTTP and HTTPS web socket for traffic distribution. So once again, CloudFront will not work with TCP and UDP. So this option is also ruled out. The last option, what we have is Amazon API. That is Amazon API Gateway. It actually uses WebSocket protocol between the client and the server. So option B, C, and D will not go well with our requirement. Here, the answer should be A. Yes, that's correct. So deploy a network load balancer, configure it to publicly accessible over the TCP port that the application requires. This is the correct answer. Let's move on to the next question. Here is the second question. A company is using a centralized AWS account to store log data in various Amazon S3 buckets. As a solution architect, you are responsible for making sure that the data is encrypted before it is uploaded into S3 bucket and also while it is in transit. That means the data should be encrypted before uploading, as well as it should be encrypted while it is in transit. So which approach satisfies these criteria, these 2 criteria? We have 4 options to go with. There is one correct answer. Let us evaluate each of the answer. The first option is A, use client-side encryption to encrypt the data that is being uploaded into S3 bucket. How does this client encryption work? Client encryption will encrypt the data before even sending the data to the S3 bucket so that the data is very much safe while it is in transit. So this answer is actually correct for our requirement. This will suit our requirement. However, let us evaluate other options also. Let us see, is there any other answer that will suit our requirement? Option B is talking about server-side encryption, server-side encryption to encrypt the data that has been uploaded to S3 bucket. So here what happens, the data, once it is uploaded into the S3 bucket, then the data is encrypted. So the data is very much safe once it is uploaded into the S3 bucket. So this option will not go well with our requirement, because our requirement is the data should be safe. It should be encrypted while it is in transit. So the option B is ruled out. Option C and option D. Option C, bucket policies that require the use of server-side encryption and manage S3 managed encryption keys. As we have already discussed, server-side encryption will not help. Option D is enable the security option to encrypt the S3 buckets through the use of default AWS key management service, that is KMS. So here, the data, once again, it will not be encrypted while it is in transit, just like option B. So the correct answer here is option A. Use the client-side encryption to encrypt the data that is being uploaded into the S3 bucket. All right, let's move on to the next question. Okay, here is the third question. A company is building an online multiplayer game. The game communicates by using UDP, and low latency between the client and the backend is important. The backend is hosted on Amazon EC2 instances that can be deployed to multiple AWS regions to meet the demand. The company needs the game to be highly available so that users around the world can access the game at all times. As a solution architect, what do you do to meet these requirements? We have four options available, and there is only one correct answer. Let's evaluate each of these answers so that we can pick the correct one. Out of four answers, the option A and option D are talking about Amazon CloudFront. Amazon CloudFront feature is meant for S3 buckets and mostly for static web pages to cater, not meant for interactive games. So the option A and option D are ruled out. Next comes the option B. It is talking about application load balancer to distribute traffic to EC2 instances. How does application load balancer works? It works within the region. It cannot go out of the region. It cannot span across multiple regions. So option B is also ruled out. It will not suit our requirement. So the last option, what we left out, is option C. It is about network load balancer and also global accelerator to route the traffic. How does network load balancer works? Network load balancer, specifically, it works with TCP and UDP. And also, it is exclusively meant for managing a low latency. Same time, global accelerator works as a cross-region load balancer. So when both network load balancer and global accelerator used together, it will meet our requirement. So here, the correct answer is option C. Deploy network load balancer to distribute the traffic. Also use AWS Global Accelerator to route traffic to region endpoint. Okay, let's move on to the next question. Here is the fourth question. A weather forecasting company needs to process hundreds of gigabytes of data with sub-millisecond latency. The company has a high-performance computing environment in its data center and wants to expand its forecasting capabilities. You must find a highly available cloud storage option that can manage massive amounts of data and can simultaneously accessed by thousands of compute instances. What is your choice? We have four options to go with. Let's evaluate each of the answers so that we will get the correct one. In real-time scenario, what exactly we do. The option 1, use Amazon FSx for Lustre Scratch file system. There are two answers. You can see A and B is one category, C and D is another category. Okay, so now to narrow down our answer, first let us evaluate A and B. Amazon FSx Lustre Scratch file system and Lustre persistent file system. How exactly Lustre Scratch file system works? It is designed for temporary storage. Okay, so this file system can be used when we require cost-effective storage for processing heavy short-term loads, not for long-term loads. Okay, so as per our requirement, it is we have long-term requirement. So the option A will not go well with our choice. Option B, it is Lustre persistent file system. This particular file system is designed for longer term workloads as compared to option A, and also for applications that require fast storage. So this also supports concurrent access to the same file or directory from thousands of compute instances. So this option B, that is Amazon FSx for Lustre persistent file system, will go very well with our requirement. So let us also try to evaluate option C and D. So that means we have narrowed down our choice to option option B, correct? So let us evaluate option C as well as option D to understand how it works. Between option C and D, option C, how it works. Here we have bursting throughput mode and provisioned throughput mode, correct? So bursting throughput mode is used when there is less amount of data to handle. That is option C. Option D, provisioned throughput mode is used when there is massive amount of data that you want to migrate from data center to AWS or vice versa, whatever. Okay, so option D also will go very well with our requirement. So we have one option B and another one option D. Both are very similar. Both will suit our requirement. But here we need to go with one answer, correct? So either you go with option B or option D. Most of the industry veterans, they go with option B. Okay, so that majority of them, they pick option B as the correct answer. But in my case, considering the real-time scenario, I choose option D to fulfill the requirement. Why? On one criteria, I consider one criteria between option B and D to choose option D. Here we need to understand how does this persistent file system works. If we choose the persistent file system, the storage capacity needs to be manually increased, and that too, it can be increased only once in every 6 hours. That means, let us say you have 2 terabyte of hard disk storage, and the hard disk storage is getting consumed. You're facing a crunch of storage space. So manually, you will have to increase the storage space. Let us say you have added additional 2 terabytes of storage capacity. And within 3 hours, this additional storage that you have added, that also getting consumed. So once again, if you want to increase, you cannot. Moreover, every time you will have to manually increase it. Whereas in case of option D, Amazon EFS with provision throughput mode, it automatically scales up and scales down. So as a solution architect, I want to go with a particular feature option that will suit very well with my requirement. I don't know how the data is consumed, how we need to scale up or scale down the storage requirement. So though majority of the people, they choose to go with option B, considering the live scenario, option D will go very well with our requirement. That is, use Amazon EFS, Elastic File System, with provision throughput mode. This is the correct answer. Okay, let's move on to the next question. All right, here is the next question. A company is developing an internal application that uses a PostgreSQL database. The company has decided to host the database on Amazon Aurora. The application does not need to be highly available, but the data must be stored in multiple availability zones to maximize the durability. Which database configuration meet these requirements and most cost effective? So we have 4 options to go with. Let us evaluate each of the options to narrow down our choice. Here we need to consider 2 main requirements. One is highly available, and another one is cost effective. Correct? Most cost effective and highly available. We need to consider these 2 while choosing our answer. So the first option here is Aurora PostgreSQL database cluster with a single database instance. Let us try to understand how does this work. A single database engine is the most basic implementation of Aurora feature. There is no high availability and also the data durability. So the first option will not go well with our requirement. The high availability, it is not meeting. Whereas the cost effective, it is meeting, but the other option requirement, it is not meeting. So option A is rolled out. Next is option B, PostgreSQL database cluster with a primary database instance with read replicas. So here, how does it work? It supports our requirement of high availability, but the data replication happens within the same availability zone. So if the availability zone data center fails, then our data, whatever the stored in that availability zone, would be lost. So this configuration also will not go well with our requirement, because we need most cost effective, highly available, and also maximize the data durability. We have 3 things to consider: maximize durability, the data durability, cost effective, and highly available. All the 3 has to be met. So the third one is the option C is with PostgreSQL database cluster with multi-availability zone deployment option enabled. How does this option works? The data is secured. The data is available in multiple availability zones. And this approach will actually meet our requirements, because it will increase, number one, the high availability, what we have marked down here, and the data replication happening in maximum availability zone, that is also happening. And further comes the cost. So cost also, it is meeting. It is very well within our requirement compared to other options available. The option D also meets the requirement of option C, whatever the highly available, maximizing durability, but not the cost effective. How? Option D, PostgreSQL global database cluster, what happens? The data is getting replicated across regions in more than one region. So thereby what happens? It will not meet the cost effectiveness requirement, though it will meet the requirement of highly available and maximizing durability. Cost effectiveness, it will not meet. So for this question, the answer is option C. Option C will go very well with our requirement. Amazon Aurora PostgreSQL database cluster with multi-availability zone deployment. Same time, if it is in a real-time scenario, as a solution architect, if you need to choose, then obviously we will select option D, because we are willing to spend. We need to protect our data. We don't want the data to be available only in one availability zone. But when it comes to exam-based question, we need to consider all the parameters, right? highly available, maximizing durability, and cost effective. So thereby, the option is here. The correct answer is C. It is Aurora PostgreSQL database cluster with multi-availability zone deployment option enabled. All right, let's move on to the next question. So here comes the next question. A social media company allows users to upload images to its website. The website runs on EC2 instances. During upload request, the website resizes the images to a standard size and stores the resized image in Amazon S3. Users are experiencing slow upload requests to the website that needs to be fixed. Which combination of action will you take to improve users' experience and improve the upload speed? We have 4 options to go with. There are 2 correct answers we need to pick. All right, let's evaluate. Let us evaluate option A. Configure the web server to upload original images to Amazon S3. Let us try to understand how does this particular feature works. What is the workflow? Okay, so here the user uploads the file to the web server first. That is, web server is our EC2 instance. So this web server stores the image file that the user uploaded into a temporary workspace like cache memory or onto the EBS volume hard disk. Then the user has to run a script. Okay, this script will schedule at a particular time, maybe every 1 hour or 2 hours once. This script will run. This script will upload the file into the S3 bucket. Correct. So though the process looks simple, it is time consuming because uploading the file to S3 bucket and then later getting that file converted or getting resized to the requirement will take longer time, right? Because the script has to run, then the file has to get uploaded into the S3 bucket. Only then the S3 bucket will be able to do the changes to the image file. So it's a time-consuming process. So the option A will not go well with our requirement because our requirement is the user has to experience the improved upload speed. So though the user is able to upload the file instantly to the EC2 instance, that is a web server, from web server, the file to get uploaded into the S3 bucket. Once again, if the user want to access that file from S3 bucket, it takes a longer time. So option A will not go well with our requirement. So next comes the option B. So here what happens, the user uploads the image into the S3 bucket and S3 bucket will invoke a Lambda function. So this Lambda function has got a code that software code will resize the image. It makes sense, right? So the user is directly uploading the file into the S3 bucket rather than uploading into the web server, from there getting uploaded into S3. So one stage is eliminated. So the user is directly uploading the file into the S3 bucket so that S3 bucket will trigger a Lambda function. Lambda function will resize the image. This makes sense. So option B should be one of the choice among our 2 choices that we need to pick. So let's evaluate option C and D. Option C, how it works. So here, any user who has a pre-assigned URL to the S3 bucket, so that user can upload the file image directly into the S3 bucket. So this also makes sense, correct? So as it is time saving, just like option B, the user is uploading the file directly into the S3 bucket. In case of option B, if the pre-assigned URL is not available, then option B will not work. Okay, pre-assigned URL should be there. It is like you giving access to the user, like administrative access or writing permission to S3 bucket. So with option C, what happens? The user has got the pre-signed URL. With that URL, he will upload the file, the image, directly into the S3 bucket. So this is another correct choice. So option B and option C, both will go hand in hand. If we select both of these options, if we meet both these requirements, this should serve the purpose. Let us also see option D, how it works. In what way option D is different. Option D is also correct answer here. Let us see the flow to understand. Is it cost effective? Is it a time saving? In case of option D, the flow is first, the user has to upload the image into the S3 bucket. Okay. S3 will trigger AWS Lambda function to perform the task. So AWS Lambda will perform the task of resizing the image. Same time, it will trigger a notification alert. This notification alert will reach the CloudWatch, because CloudWatch is a metric, right? So CloudWatch will be able to monitor what is the change happening in the S3. The writing is happening, the modification is happening, all those things. So CloudWatch will trigger another function for Lambda to perform any specific task like modification, addition, deletion, whatever. That task we have already performed in step 2, correct? So here what happens, the process is getting duplicated. So though option D, that is create an Amazon CloudWatch event rule to invoke AWS Lambda function to resize and upload the image, that we have already achieved even before the AWS CloudWatch get to know the alert notification. So the simplest, easiest choice is option B and option D. So with this, we'll be able to perform the task. So our answer should be B and C. All right, let's move on to the next question. Here is the next question. A company uses on-premises servers to host its applications. The company is running out of storage capacity. The applications use both block storage and network file storage. Now, the company is looking for high-performing solution that supports local caching without reattaching its existing applications. Which action will you take? Out of 4 available options, we need to pick 2 correct answers. So let us evaluate each of the answers so that we will be able to narrow down our choice. The first option, mount Amazon S3 as a file system to the on-premises servers. Let us try to understand how Amazon S3 works. First of all, Amazon S3 is a block storage. It cannot be used or mounted as a file system. What is a file system? Attaching like a drive C. Okay, so Amazon S3 cannot be attached as a file system. So as per our requirement, option A is ruled out. That will not help. That will not work. Next comes option B, deploy an AWS storage gateway file gateway to replace NFS storage. Let us try to understand what is a storage gateway. Storage gateway is a service, AWS service, that connects our on-premises software applications with the cloud-based storage to provide seamless and secure integration between the on-premises IT environment and the cloud storage infrastructure. So as per our requirement, yes, this option B is the best choice between A and B. A will not work at all. So as of now, B is one correct answer. Let us evaluate other 2 more options so that we will understand B, will it really go hand in hand with our requirement or not? Let us evaluate option C. Option C is deploy AWS Snowball Edge to provision NFS mounts to on-premises services. Let us understand what is a Snowball, how it works. Snowball Edge is a petabyte scale data transport or migration service to move data from on-premises to AWS or into our S3 bucket. So our primary requirement here is to mount as a file system. Okay, though option C, Snowball Edge can be used for moving data from on-premises to cloud, we should be able to use this service as a file system, like attaching like drive C, drive D. So option C also will not go well with our requirement. So option A and option C is rolled out. So we have only one option left apart from the correct answer, option B, that is option D. Option D is deploy AWS storage gateway volume gateway to replace the block storage. How does this works? So here, unlike our, just like our option B, this will also do the same purpose. So this will move data from on-premises to the any convenient storage solution, that is the network file storage for locally caching and storage purpose. So option B and D both will do the needful. So we need to have both option B as well as option D to meet our requirement. So one is deploy an AWS storage gateway file gateway to replace NFS storage, and D is deploy AWS storage gateway volume to replace the option here. The answer what is given A and D is wrong. It is B and D, option B and D. Okay, let's move on to the next question. Here comes the next question. A user wants to list the IAM role that is attached to the Amazon EC2 instance. The user has login access to EC2 instance, but does not have IAM permission to get the details. What command that the user should run to retrieve instance metadata? So here we have 4 options to go with one correct answer. Before analyzing the answer, let us try to analyze the question itself. Okay, let me put it this way. You as a user have login access to the Amazon management console. You have access to log into the EC2 instance that has been hosted. So you will use a PuTTY or any other software, SSH, you will log into this EC2 instance. But no IAM role is attached to you. You have your username is created. You have access to log into EC2 instance, but there is no specific IAM role attached to you. Thereby, you will not be able to perform any task. But your job is to retrieve the instance metadata, okay, the details of that virtual machine, which command you will run here. Okay, so there are 3 answers. A, B, C belongs to one category. Answer D is another category. The option A, B, C commands, the curl command, this works in Linux-based machines, virtual machines. Okay. Option D, AWS IAM, that works in PowerShell, in Windows-based. All right. So here, to pull out the metadata, it will go with any of the curl commands. Okay, with PowerShell command that will not help to pull the information. So the curl command, we need to choose the answer between A, B, and C. One is correct answer. In the question itself, it is clearly given what command that the user should run to retrieve the instance metadata. The option A. Okay, option A, it gives a curl HTTP, that 169.254.169.254 IP address, latest /meta-data/IAM/info. This is the correct answer. Okay, so other options will not work. And here, the question should have been more specific, correct? They could have mentioned what command that you need to run either in Windows or Linux-based virtual machine, so that the answer could have been much easier to find. All right. Okay. Anyway, the answer is A, using the meta-data/IAM/info command. All right, let's pick the next question. So the next question is, a company is using AWS organizations with two AWS accounts. One account is called logistics and another account is called sales. So the logistics account operations and operates an Amazon Redshift cluster. They have their database in Amazon Redshift cluster. The sales account is using Amazon EC2 instance to manage their day-to-day activities. The sales account needs to access the logistic accounts data available in Amazon Redshift. What is your recommendation to meet this requirement most cost effectively? Here is a catch. So maybe you'll be able to perform all the options, whatever is given, it may go very well, but it should meet the most cost effective way. So let us evaluate the answers. So here, option A and B will go very well with this requirement. Option C and D is completely ruled out. That is option C, create a snapshot of Amazon Redshift cluster, then share that snapshot with sales team, restore that snapshot into to get the data of logistics by accounts. Those are all very, very lengthy way, and it is not cost effective. Similarly, option D, copy the data from Amazon Redshift to Amazon S3 bucket. From there, you download, expand that database. No, that is also ruled out. So either it should be option A and option B. So in case of option A, it is the most cost effective because you just simply set up a VPC that shares logistic accounts as the owner, and the sales account will be as the participant to transfer the data between themselves. This is the most cost effective compared to option B. Why? In case of option B, create an AWS Lambda function in the logistic account to transfer data from Amazon Redshift to Amazon EC2 instance in sales department. Once again, it is not cost effective and also time consuming. So here the simplest answer, the easiest choice is option A to go with. So set up a VPC sharing with the logistic account as the owner. You make the logistic account as the owner and sales account as the participant to receive the data. This is the most cost-effective way of sharing the data. All right, let's move on to the next question. Here comes the last question. A solution architect must design a highly available infrastructure for a website. The website is powered by Windows web servers that run on Amazon EC2 instances. You must implement a solution that can migrate large-scale DDoS attack that originates from thousands of IP addresses. Downtime is not acceptable for this website. So what action as a solution architect you will take to protect the website from such attack? We have 4 options to go with and 2 correct answers that we need to pick. So let us try to evaluate each of these options. Option A. Option A is talking about AWS Shield. What is this AWS Shield? How it works? AWS Shield, it has got an advanced option, 1 options to go with. This particular feature is specially meant for stopping DDoS attack. What is DDoS? Distributed denial of service. It is like keep sending a ping request, echo request to a particular IP address or a website, so that there will be so much of web traffic that gets onto the web server that the server will crash. The intention is to crashing the server. That is called DDoS attack. So this AWS Shield advanced option is specifically designed by AWS to protect the web servers from DDoS attack. So the option A is one of the correct answers among 4. So let us narrow down to A. Meanwhile, let us evaluate the other options. Option B is configure Amazon guard duty. How does this work? What for it is meant? Amazon guard duty, this feature is provided to stop only the malicious activity. Okay, it will not stop DDoS attack. DDoS, it will allow. If there are any malicious activity, only that will be stopped. So option B will not help us anyway. And how about option C, option D? In case of option C, you can see we have Amazon CloudFront. Okay, how does CloudFront will work? It will distribute the website content across multiple edge locations. Suppose a particular web server is keep getting a DDoS attack. There is so much of web traffic to that particular web server, right? So immediately the CloudFront, what it will do, it will move the remaining request, other genuine website requests to other locations so that the traffic is distributed. This will eliminate the downtime of a web server or a website. So option C is also correct choice. So if we go with option A and option C together, we should be able to meet our requirement. So option D, once again, it is completely rolled out, running a AWS Lambda function automatically and adding that into IP address to the VPC and access control list. Keep checking for these IP addresses, whether it is keep sending the echo request or ping request. Here, what happens? It was clearly mentioned the DDoS attack that originates from thousands of IP addresses. How many IP addresses will we keep adding? Every time this DDoS attack will be using a different IP address to attack. So you cannot keep on doing the same job back and forth, right? So option A and option C will go very well with our requirement. Okay, so that is use AWS Shield Advanced to stop DDoS attack and configure the website to use Amazon CloudFront for both static and dynamic content. So with this, we have reached at the end of today's quiz. Thank you so much for your participation. We'll have a lot more questions in the upcoming session. Thank you.